this is part 4 of the Sun, Earth, and Moon system that I have made. And today I'm going to explain like why my model isn't like the most accurate, and like what if we apply this to like a different planet. Alright, so why my model isn't the most accurate? Alright, for starters, if this Earth was the size of this basketball, right? The moon would be like the size of a tennis ball, which is 1 inch wider than this ping pong ball right here. And then the sun right here would actually be 109 times wider than this basketball, which would probably be larger than this house I'm in right now. Way large, mega large. Alright. Also in the last videos, I forgot to like mention a few things, and it will apply to like the other planets. Alright, day is just how long it takes for like object to rotate once around its axis. A year is how long it takes for an object to revolve around another object. The light year is just how long light takes to travel in 1 year. I also forgot to mention how moon phases occur. Moon phases occur because the light from the sun reflects on the moon, right? Let's just turn this on just to demonstrate a bit. Right here, as you can see, from Earth's perspective, half of it is lit and half of it isn't. And then let's say it was behind the Earth, right? All of it is lit now. And if it was, let's say Earth was over here, none of it is lit. So it's just the angle of the moon and also the angle of the sunlight that is hitting the moon. Also, right, now let's just get into the next model, which would be the Sun, Mars, and its moon Phobos system. Hey, right? If you come here, and I'll turn on the sun, you will see it is basically the same size, basically the same shape, and basically like the same tilt of the Earth, just like this, right? It gets the same seasons as us because it basically has the same tilt. Like the winters are probably as cold or even colder since it has more of a tilt, and the summers are probably even hotter because it has more of a tilt. And the spring and fall is probably the same temperature. Alright, now let's get into the eclipses. Right? If we move over here, you can see that, right? It only gets this partial, the penumbra shadow right here. And that is because this moon, right? It's so small that it cannot, and it's so small and so far away that it cannot make an umbra on Mars. Also, it can also make annular eclipses because, well, if the penumbra is like this and it stops right here, there would be like this small gap right here which would see light. And then same with the lunar eclipse, right? If I move the sun over here, you would basically see, I mean not the sun, the Mars. You would see like, oh, Phobos is just totally blocked out by Mars since Mars is so large compared to its moon. Alright, that's all I have for you today. Hey, thanks for watching.